Hello everyone. In this video, I want to introduce our work Couplformer, Rethinking Vision Transformer with Coupling Attention. The terminology Couplformer is made by ourselves, which means coupling a transformer. Transformer have become one of the most popular deep learning models for common machine learning tasks, such as natural language processing and computer vision. However, there are several issues with this architecture. The most annoying problem is the high memory consumption of attention mechanism. As the key component in transformer, the attention mechanism brings more efficient representation. At the same time, it also leads to a quadratic space complexity with respect to the input size. For instance, for an input image of size 224 × 224, we use a kernel of size 16 × 16 for patch embedding and get a flattened sequential token which length is 196, and attention matrix size is 196 squared. But in some medical image recognition scenario, the lesion region is relatively small in the image. A larger image input size is requisite for feature extraction, and when we increase the input image size to 512 × 512, the attention matrix size will come to 1024 squared, which is about 27 times larger. This means we need 27 times more computing resources to keep the same training recipe, which is unacceptable for small companies and research groups. To tackle this problem, we propose Couplformer based on coupling attention. The main idea is finding a way to decrease the size of attention matrix. Tensor decomposition is widely applied in the lightweight design of neural network. As well known, a matrix can be represented by the chronic product of two small matrices. We want to decompose the attention matrix into two sub-matrices A and B, which can reduce the space complexity from HW times HW to H times H plus W times W. For the input image of size 512, the total size of sub-matrix A and B is 512 times less than the traditional attention matrix. Another advantage of coupling attention is we can calculate the output of attention without computing the attention matrix explicitly by vector trick. The specific implementation can be seen in the paper and the code. Then there is only one question left: how to generate the submatrix A and B. We apply the preconceived setting of size A and B with H times H and W times W respectively. Then it's natural to construct the submatrix by calculating the alignment score between the vector along the height and the width axis rather than the channel axis to get A and B. From the equation, we can consider the element of attention matrix is the product of row alignment score and the column alignment score between two positions on the 2D feature map as shown in the right figure. Based on the coupling attention, we design a Couplformer layer which is stacked to construct an end-to-end deep learning model similar to the VIT for different CV tasks. Extensive experiments has been carried out to demonstrate the effectiveness of Couplformer, including image classification tasks on CFAT 10 and CFAT 100 and ImageNet 1K, as well as the downstream tasks such as object detection and instant segmentation on MS COCO 2017 outperforms. The result shows Couplformer can achieve comparable performance while requiring much less computation resources. This is all about the Couplformer. Thanks for listening.